All right, folks, today we'll do a very simple talk on making a tone or sine wave, uh, in our case a 1 gigahertz sine wave, using GNU radio. The first thing I'd recommend is uninstall any of your current GNU radio if you have it installed. Get it off your computer, get it all cleared away, and go ahead and Google Radio Conda. That is what you want to install. In my case, I'm running Windows, so I installed the Windows one. But this is a very up-to-date package, has all the GNU radio goodness, so it's been a recent update, and I would highly recommend getting this installed on your computer, particularly if you're running Windows. And for our hardware today, we'll be using the USRP B200 Mini. I get it on eBay because it's significantly cheaper, almost half the price or more than the Edis Research website, but you can choose wherever, but I've proven that these have worked just as well and probably are from the same factory, just a lot cheaper. All right, so to bring up GNU Radio, you go to the little start thing on your computer, go to G, and then under G should be this GNU Radio companion, and that's what you click. All right, so this is a block diagram to simply make a tone at 1 gigahertz. Now some of you might be looking at this as like, how can sending a constant number 1 give us a 1 gigahertz sine wave? And what you have to know or understand is that when you see these sync blocks in GNU Radio, they are essentially an IQ modulator block. And you look in that block, you see the sample rate and the center frequency. That center frequency is essentially the carrier or the output frequency at which the signal is going to come out. So in our case, since we just want a simple tone, the IQ data is simply going to be 1, right? And that's what's shown here. So if you run this block and look at the output of the USRP, you will see a tone at 1 gigahertz. And again, just to know that the I data is 1, the Q data is 0. So when you see the blue, I guess, in the GNU radio thing, that means it's a complex stream, right? If you see orange, that means it's not a complex stream. So a little GNU radio lingo there. So we hook up the tone to our spectrum analyzer. The spectrum analyzer has been recently calibrated, and we see that our tone is off by 800 hertz. So what should we do? Should we pop open the lid of our little hardware device and get our little frequency adjustment screwdriver? No. We're going to fix it in software. You see, folks, the reason why hardware engineers love software-defined radio is because if there's any problem with the hardware, they simply fix it in software. And the reason why software engineers hate hardware engineers is because the hardware engineers just throw all their problems to the software engineers. So that's a little background story. So here is how we can shift our signal down by 800 hertz. We have to multiply it by a negative 800 hertz sine wave because it was 800 hertz above 1 gigahertz. So we need to shift it down by 800 hertz. So that is why the frequency is negative. And again, the blue means complex. So it says a waveform called cosine. It's not really a cosine. It's really the equation shown at the bottom. It's a complex phasor. And so by doing this product, we now shift our baseband signal by 800 hertz lower. And now when we look at the spectrum analyzer, we should see the tone exactly at 1 gigahertz. So this is how we can do fine frequency adjustment back in the software domain. And here is a final product of how we could turn this into a upper sideband transmitter centered at 1 gigahertz. We feed in the audio rate's 20 kilohertz, we bandpass filter it, we then run that through what's called a Hilbert transform, which turns the audio signal into a complex signal. So now we have essentially an upper sideband signal. We upsample it by 50, so now our sample rate is 1 megahertz, and we're shifting that by 800 hertz down to account for the oscillator that was not very good in the USRP. And I have a little scaling there, a fast multiply constant, just to reduce some of the spurs I was seeing. But anyway, this diagram is a proper diagram of how you would do an upper sideband transmission. If you wanted to do lower sideband, you would simply inject a complex conjugate block right after that Hilbert transform block. So this is our video today, a very simple talk on using GNURadio to make a 1 gigahertz sine wave. Thanks for watching and have a great day.